This is the 11.1 to 11.4 practice assessment. In section 11.1, we talked about working with radicals, simplifying radicals, rational exponents that were actually radicals. So in problem 1, we want to express the fourth root of 81, a to the 8th, b to the 12th using rational exponents. We start by rewriting the fourth root as the 1/4 power. So 81, a to the 8th, b to the 12th, to the 1/4 power. That 1/4 power gets distributed to everything inside the parentheses. That includes the 81. So 81 to the 1/4, a to the 8th to the 1/4, and b to the 12th to the 1/4. Here, the property of exponents tells us to multiply those exponents together. So 8 times 1/4 is 8 over 4, which is 2. And 12 times 1/4 is 12 over 4, which is 3. But in order to simplify 81 to the 1/4, we need to rewrite 81 as a prime base raised to a power. Remember, the prime numbers are 2, 3, 5, 7, 11. 2 is the only even prime number. The rest of them are odd. Not all odd numbers are prime. 81 can be rewritten as 3 to the 4th power. And then you would multiply those exponents together. 4 times 1/4 is 1. So the answer is 3a squared b cubed. In number 2, simplify the fifth root of 64a to the 6th, b to the 10th. Well, because it just says simplify, what we want you guys to do is we want you to rewrite it as a radical, not with rational exponents like in problem 1. The way I like to do this problem is I like to write everything out in prime factorization. You know, like if you make a little factor tree, like this is 2 times 32, and then 2 times 16, 2 times 8, 2 times 4, and 2 times 2. You'll find out that 64 is 6 2's. So I'm going to erase this, and now I'm going to rewrite it. 1, 2, 3, 4, 5, 6. There are 6 A's, and there are 10 B's. 8, 9, 10. Little multiplication symbols between them. A fifth root is 5 of the same item in a group. So I would circle 5 of the same item. How many of each group can we take out? So how many groups of 2 can we take out? Well, there's one group of 2's. There is one group of A's. There are 2 groups of B's. But underneath the fifth root, there's still a 2 and an A that we didn't circle, so they remain under the fifth root. So the answer is 2ab squared, fifth root of 2a. In problem 3, the residents of the city of Mathville decreases at a rate of 0.6% per year. There were 10,165 residents in 2001. How many will there be in 2020? There's no real way to know which equation to use, so I'm actually going to show you both. This was one of the equations for increasing and decreasing that we used, and the other one was the one involving E. If you use the first equation, the initial population of the town is 10,165. Remember that in order to change that percent into a number we can use, you have to divide it by 100. That's the same as moving the decimal 2 places to the left, so it's going to be 0.006. And since 10,165 is the number of residents in 2001, T will be the number of years since 2001. We want to find the number of residents in 2020, so that'll be 19 years. Remember, because it said that it's decreasing, there's a minus sign here. And then I plug it into my calculator, and I round to the nearest integer, and I find out that it's going to be about 9,067 residents. If I use the other equation instead, I'm going to get a slightly different answer, but it will be in the same general area. So the initial population is 10,165. E to the, now I have to make K negative because it's decreasing, 0.006 times 19. And when I shove that in my calculator, I get approximately 9,070. So which one should you use on the test? Makes no difference to me, as long as whichever one you use, you get the correct answer for that equation, and I will give you the credit. In number 4, Laura Lee has $1,300 to invest in an account that earns 5% interest. How much will she have in 10 years if the account is compounded quarterly or if the account is compounded continuously? These are two different equations. Continuously is the PERT equation. Any other type of compounding is this equation. So compounding quarterly means that n is 4. I'm going to change the rate to 0.05. And so when I plug it into my calculator, it's going to be 1,300. 1 plus 0.05 over 4 raised to the 4 times 10. And I'll probably change this to 40 before I plug it into my calculator. When I plug it in, remember that it's money, so you need to round to the nearest hundredths place. You should get, let's go back, $2,136.71. For compounding continuously, you'll do 1,300 E raised to the 0.05 times 10. And when you plug that in your calculator, you should get approximately $2,143.34. Number 5, the yield Y in millions of cubic feet of trees per acre for a forest stand that is T years old is given by the equation Y equals 6.7 E raised to the negative 48.1 over T. The first question is the yield of trees increasing or decreasing? Well, it's decreasing, and the reason it's decreasing is because the rate is negative 48.1. In part B, what is the projected yield after 15 years? So we're going to plug in 15 for T, and I want you to remember here that it says the yield is in millions of cubic feet. That means that you have to multiply your answer by 1,000,000 at the end. So 6.7 E to the negative 48.1 over 15 is going to give me approximately 0.259. Well, that doesn't make sense for a number or yield of trees. So because it says it's in millions of cubic feet, we're going to multiply it by 1,000,000, which means it's going to be 259,143 cubic feet. In number 6, evaluate the log base 5 of 1/5. I like to set this equal to x, and then we're going to rewrite it in exponential form. So it's going to be 5 to the x is equal to 1/5. The only way to raise a number to a power and get a fraction is if the exponent is negative. So it doesn't take very long to figure out that x is negative 1, because 5 to the negative first power is 1 over 5. In part B, I'm going to rewrite the log base 36 of 6 equals x as 36 to the x is equal to 6. Well, how am I going to rewrite a number to a power and get a number that's smaller than it? That's because x is going to be a fraction? Well, x is going to be 1/2, because 36 to the 1/2 power is 6. 36 to the 1/2 power is the same thing as the square root of 36. In number 7, rewrite 1/4 raised to the -2 equals 16 in logarithmic form. So it's log, and then the base is 1/4 of 16 equals -2. And part B, we want to rewrite the log base 16 of 2 equals 1/4 in exponential form. So it's going to be 16 to the 1/4 equals 2. In the last problem, we're going to use our properties of logarithms to simplify the logarithms. We can't solve a log equation if there's more than one log on either side of the equation. So in part A, first I want you to notice the numbers in front of log. Those get written as the exponents. Now it probably helps to simplify those a little bit. So this is going to become log base 8 of 16 plus log base 8 of 3. Let's make that look like an A. Then, once I get rid of the numbers in front of the log, now, because these are being added, the property of logs says I can rewrite it as 16 times 3. And 16 times 3 is 48. Last but not least, if you have two logs with the same base equal to each other, those cancel, and it turns out that A is 48. I'm going to do this one more time. With B, notice that the two already have logs that are equal to each other. So right now I'm at 2x plus 3 equals 15, and then all I have to do is solve that two-step algebra equation, and I find out that x is 6. And that was the 11214 practice assessment.